Hello, this is a quick refresher on Sn2 reactions. I'm sorry, my voice is a little off today. I'm under the weather, flu. Anyways, let's. This is a metal transferase um, reaction in which a metal is transferred to a DNA. A methylation is a common uh, method of basically distinguishing the old DNA strand from the new DNA strand. But that's irrelevant. And now we're looking at basically the chemical reactions. Now we have an aspartic acid here, which has a side group that has a negative charge on it. Now, of course, this oxygen that has valence electrons here, and uh, in this case, a negative charge on it too, right? Oxygen makes double bonds. It needs two electrons to complete its outer shell. In this case, it has only one, so it will want to react with hydrogen. Now, on this part right here, the only hydrogens are these. But another mechanism that stabilizes everything else, the ring structures, is, for example, I can write the same molecule in a following manner. And instead of putting double bonds like it is on the picture, I can put double bonds like these, like this here. And again, NH2, this is the same molecule, but the rings are in a resonance. They are stabilized with these resonance structures, so these can go back and forth. Anyways, what we have here, let's break it down into two steps, even though it's not going to be, it basically, there are two reactions here, but let's see what's happening, and chop this down, the methylation process. So here, what's happening? We have a partial bond here, if you will, that is formed, and now this is for practical purposes, a single step reaction in which we have electron being uh, actually the proton being removed, from this NH bond by the negatively charged oxygen, which then liberates an electron here, and this electron readily attacks this carbon right here. And because we have a S plus here, and plus S is it's a very high state here, it cannot be in a positive, uh, cannot have positive charge. The carbon readily releases the electron to S, the sulfate. And given that carbon and sulfate have the same uh, electronegativity, it's the steric uh, effects that play a role. By steric effect, I mean basically this attack right here, this reaction right here. Let's write it down here. It kind of looks like this. H, and we have a partial bond forming with CH3S, right? And this bond right here at this stage is also partial bond. Okay, so when this bond forms, this bond is broken. So in the end, we get a methylated DNA, and we get the methyl group removed. And this system is already in a stable um, state. Well, obviously given to the pH that it is in. Well, this is it. If you'd like to try your own um, problems, let me on the next slide. I will put several reactions. Please do them and send them to me. Thank you. So here's a list of common alkyl halide reactions for excuse me, for practical purposes. We're not going to go beyond these halides, but the reactions here are quite straightforward and do not get too intimidated by other molecules. The mechanism is the same. There is the attack by OH group and the release of electron and formation of chlorine ion. That's it. So let's see if we can look at some or solve some problems. So please write out what these reactions look like, how they would proceed, and what would their final products be. Thank you. I hope it helps. Have a good day.